Welcome to the Explainer. So, you've probably been using plenty of Docker images that other folks have built. Well, today we're going to flip that script. It's time for you to learn how to create your very own image by writing a Dockerfile, right from scratch.
So let's really get into this. A Dockerfile is basically the blueprint, the DNA for your application's container. It's a set of instructions that Docker follows perfectly every single time, making sure your app's environment is exactly the same no matter where it runs.
All right, let's start with the big picture. What in the world is a Dockerfile, and how does all this magic actually happen? You might be surprised by just how straightforward the whole idea is.
So get this, at the end of the day, it's just a plain text file. But the name is super important. It has to be Dockerfile. That's a capital D with no file extension. And I mean exactly Dockerfile. Get that wrong, and Docker has no idea what you're talking about. Inside, you just list out commands, and Docker runs them one after the other, creating a new cached layer for each step.
This building a house analogy, it's perfect for understanding the process. Your from command, that's your foundation. It's the base you're building on. Then you've got run, which is all the construction work, installing your software, setting things up. Copy is like moving in the furniture. That's your actual code and files. And finally, CMD, well, those are the house rules. It's the one command that runs as soon as someone walks in the door, or in our case, starts the container.
Okay, concept down. Now, let's get our hands dirty. We're going to break down the most essential instructions you need. We'll go line by line and see how to build a real image for a simple Python web app.
First things first, every single Dockerfile must start with from. I'm serious, this is the one rule you can't break. It specifies the parent image you're building from. You're not starting from nothing, you're starting on a solid foundation, like say the Python 3.11 Slim image. And using a Slim version is a great pro tip, by the way. It keeps your final image nice and small.
All right, next up we've got workdir. This is basically like typing CD in your terminal. It sets the working directory for all the commands that follow it. And here's the cool part, if that directory doesn't already exist inside the image, workdir will just create it for you. Pretty handy, right?
Okay, copy is pretty much exactly what it sounds like. Its job is simple. Take files from your local machine, what Docker calls the build context, and copy them right into the image. You just tell it the source and the destination. Done.
Okay, pay attention here because this one's super important. Run. You have to understand that run executes commands during the build. This is when the image is being created. It's where you install all your software packages or compile your code. This is how we'll install our Python dependencies. And this is totally different from our next key command, CMD.
Now, expose is a classic gotcha for beginners. A lot of people think this command magically opens a port on their computer. It doesn't. Expose is literally just documentation. It's like putting a label on the container that says, hey, the app inside me likes to listen on this port. You still have to do the actual port publishing later when you run it.
And that finally brings us to CMD. So, while run happens at build time, CMD is what happens when the container starts. It's the default command that kicks everything off. You only get one of these, and it's the main process that keeps your container running. So, remember the house analogy? Run builds the house, but CMD is what happens when you open the front door.
All right, so you know the basic commands. That's awesome. But just knowing the words isn't enough, right? The real trick is using them to build small, fast, and secure images. So let's talk about some best practices that are going to save you a ton of headaches.
This is a huge one. The order of your commands matters a lot. Why? Because of something called layer caching. In that bad example, every time you change even a single line of your app's code, Docker has to reinstall all your Python packages. But in the good example, we copy just the requirements file first, install everything, and then copy our code. That way, Docker only reinstalls dependencies if that one specific file changes. It's way faster.
And here is another classic mistake. If you use run to start your app, it will literally start and then stop during the build process, and your final container will just do nothing. I'll say it again. Run happens when you build the image. CMD happens when you start the container. It's a big difference.
Okay, here's a pro tip that'll save you so much time and make your images way better. Use a Docker ignore file. It works exactly like a .getignore file. You just list out all the stuff you don't want to include in your image, like your .git folder or secret.env files. This means faster builds, smaller images, and much better security. Trust me, just do it.
You might be tempted to just use latest in your from line. I mean, it sounds easy, right? But here's why that's a risky idea. The latest tag can change. Today, it might be Python 3.11, but tomorrow, it could be 3.12, and maybe that breaks your app. By locking in a specific version like 3.11 Slim, you make your builds predictable. They'll work the same way today, tomorrow, and 6 months from now. No surprises.
Okay, enough talk. Theory is great, but it's time to actually build something. We're going to take everything we've learned, put it into our Dockerfile, build the image, and launch our very first custom container.
So, once your Dockerfile is ready, you run this command, docker build. That little -T flag just stands for tag, which is basically a name for your image. We're calling ours myFlaskApp. And that single dot at the end, super important. It tells Docker to use the current directory as the source for the build.
Boom, the image is built. It's sitting right there on your machine, ready to go. Now you just run it. The magic here is the P flag. This is what actually connects or maps a port on your computer, the first 5,000, to the port inside the container, the second 5,000.
And there it is. Success. Just like that, you went from a plain text file to a real, working, totally isolated web app. That right there is the fundamental power of Docker. Congratulations, you've officially built your first custom image.
So now the question is for you. What project are you going to Dockerize first? Seriously, the absolute best way to make this stuff stick is to go try it out on one of your own projects. You've now got the superpower to package any application into a portable, consistent environment. That's a game changer. Thanks for joining this explainer, and we'll see you in the next